Welcome to our channel. Today, we're embarking on an exciting journey to create a 3D skydiving simulator using Java. This project will help you understand 3D graphics programming, physics simulation, and Java development. Make sure you have your Java development environment ready, and let's dive in. First, let's set up our environment. We'll need a couple of libraries to handle the 3D graphics and physics. We will use JavaFX for rendering the graphics and the Java 3D library for the 3D capabilities. To set up your project, create a new JavaFX project in your favorite IDE. If you are using IntelliJ IDEA, simply select JavaFX from the project templates. Next, let's add the necessary dependencies to our project. If you're using Maven, you can add the following dependencies to the pom.xml. Once your project is set up and dependencies are added, let's create our main application class. Create a new class called Skydiving Simulator. This will be the entry point of our application. Let's break down what's happening here. We are extending the application class from JavaFX, overriding the start method. Here we create a new group, which will serve as the root of our scene graph and a scene to display our content. Now, let's create a 3D environment. To do this, we need to create a 3D scene. First, we will create a camera and set its initial position. In the code, we create a perspective camera, which provides depth perception. We also move the camera back along the z-axis to allow our 3D objects to be visible. Next, let's add some terrain for our skydivers to land on. We will use simple shapes to create a ground plane. For now, let's use a box shape to represent our landing area. Here, we define a method, createGround, that generates a box with width, height, and depth of 200, 1, and 200 units respectively, giving the illusion of a flat ground. We set its color to green. Now we can add our ground to the scene in the start method by calling createGround. At this stage, run your application. You should see a green box representing the ground plane. If you see this, congratulations! You've successfully set up a basic 3D environment. Now, let's add our skydiver model. For simplicity, we will create a simple 3D shape that represents our skydiver. In the Create Skydiver method, we create a sphere with a radius of 0.5. This represents our skydiver character. The sphere is positioned at 50 units above the ground. Add the skydiver to the scene by calling Create Skydiver in the Start method. Once again, run your application. You should see a blue sphere above the green ground, which represents our skydiver. Now, let's implement basic skydiving physics. We need to simulate the gravity effect on our skydiver. We can achieve this by updating the skydiver's position during each frame. In this section, we declare variables for the skydiver's y-coordinate, fall speed, and gravity. The animation timer is used to update our skydiver's vertical position continuously based on the physics calculation. To ensure our skydiver lands on the ground, we need to check if the skydiver has hit the ground. We can do so by checking if its y-coordinate reaches or falls below 0. This code checks if the skydiver's y-coordinate has dropped below 0. If it does, we reset the y-coordinate and the falling speed, simulating the landing effect. Next, let's add some controls to restart the simulation after the skydiver lands. We can achieve this by listening to key events. In the Reset Simulation method, we restore the skydiver's initial values, allowing the user to restart the simulation by pressing the R key. Now, let's enhance our skydiver's appearance by adding a parachute. We'll use a simple rectangle shape for demonstration. In the Create Parachute method, we create a rectangle representing the parachute. We position it slightly above the skydiver to give the illusion of it being deployed. Don't forget to add the parachute to the scene in the Start method after creating it. As of now, with the parachute added, your skydiving simulator is shaping up nicely. However, let's ensure that the parachute appears only when the skydiver falls past a certain height, indicating that the parachute is deployed. In this code, we make the parachute visible when the skydiver's y-coordinate drops below 30. We also adjust the parachute's position according to the skydiver's position. Let's explore adding some wind effect to make it more realistic. We will randomly change the skydiver's horizontal position every frame. The wind effect is simulated by generating a random value and applying it to the skydiver's horizontal position. This causes the skydiver to sway left and right during their fall. Finally, let's polish up our application by adding sounds to enhance the experience. We can add background music and sounds of wind and the parachute deploying. In this section, we load an audio clip for our background music and set it to loop indefinitely. Make sure to include the sound files in your project directory. And there you have it. We have built a basic 3D skydiving simulator with Java. You can now expand this project by adding more features like obstacles, scoring, or even multiple skydivers. Thank you for joining me on this coding adventure. If you found this tutorial helpful, please give it a thumbs up, subscribe to the channel for more tutorials, and leave your comments or questions below. Happy coding!